This question is about ions and compounds containing hydrogen. Part A. Lithium aluminium hydride contains the aluminium hydride minus ion. Draw a dot and cross diagram to show the bonding in an aluminium hydride ion. Show outer electrons only. Lithium aluminium hydride itself is ionically bonded because it's the Li plus and the aluminium hydride minus that make it ionically bonded. But the aluminium hydride ion itself is covalently bonded. So if we were to draw out the aluminium hydride ion, we would draw it covalently with Al needing, well, normally it would need 3 bonds, but it's a minus, so it can have 4, with hydrogen sharing 1 pair of electrons, not forgetting the brackets and the minus charge to show it's an ion. To get the mark for this question, you need to show this whole structure correctly. You can also draw circles around the Li and H, but that's not essential. You'll get the marks for just drawing the electron pairs. Part B. Nitrogen forms NH4 plus and NH2 minus ions. Predict the name of the shape of and HNH bond angle in NH4 plus and NH2 minus. To begin, let's draw out the ions and their shapes. So for NH4 plus, it would be nitrogen with 4 NH bonds, and then don't forget the brackets and the plus charge. In this ion, there are 4 bonded pairs and no lone pairs. So the name of this shape is a tetrahedral shape. Something that has a tetrahedral shape would have a bond angle of 109.5 degrees. For NH2 minus, if we draw that out, it would be an NH and 2 of those bonds with a minus charge. In this shape, there are 2 bonded pairs and no lone pairs. So the name of this shape is a non-linear shape. The bond angle in something that has a non-linear shape is 104.5 degrees. This question's worth 2 marks. To get both marks, you need the NH4 plus ion row correct and the NH2 minus ion row correct also. Part C. Nitrogen, phosphorus and arsenic are in group 15 or 5 of the periodic table. The boiling points of their hydrides are shown below. Part 1. Explain why the boiling point of pH3 is lower than the boiling point of NH3. The first point we need to make when answering this question is that NH3 can form hydrogen bonds. These are a type of intermolecular force. Hydrogen bonds can be formed between nitrogen and hydrogen, oxygen and hydrogen, and fluorine and hydrogen. The second point we need to make is that hydrogen bonds are stronger than any other intermolecular force. To get the 2 marks for this question, we need to say that NH3 can form hydrogen bonds and that hydrogen bonds are stronger. Because they're stronger, it means they're going to require more energy, and therefore pH3 is going to have a lower boiling point than NH3. Part 2. Explain why the boiling point of pH3 is lower than the boiling point of ASH3. I've copied the table from part 1, or C, so we can just confirm that pH3 has a lower boiling point than ASH3. So minus 55 and minus 88. Again, like part 1, there are 2 bullet points we need to write for this question. The first one is that ASH3 has more electrons than pH3 and therefore has more or stronger London forces of attraction. To get the 2 marks for this question, you need to write the 2 bullet points so that or ASH3 has more electrons, and that ASH3 has more or stronger London forces.